So let us discuss some more questions. Let A not equal to In means A is not an identity matrix. Be an n cross n matrix such that A square is equals to A, where In is the identity matrix of order n. Which of the following statements is false? In minus A square is equals to In minus A. Second part, trace of A is equals to rank of A. Rank of A plus rank of In minus A is equals to n. The eigenvalues of A are each equal to 1. One, two, three. These are correct options, na? But I want to find false. Fourth one. Because these three results I have discussed in the previous class. Let A be an n cross n real matrix with A square is equals to A. Then first part, the eigenvalues of A are either 0 or 1. A is a diagonal matrix with diagonal entry 0 or 1. Rank of A is equals to trace of A. Rank of I minus A is equals to trace of I minus A. All are true. So this is a idempotent matrix.
Hmm.
Eigenvalues of A are either 0 or 1. First option is correct. In second
But this
option,
is a diagonal. If it is diagonalizable or not. You have to check this, no?
or you can discard this by taking example. I have discussed as example, na? 1 by
Mm-hmm.
2, 1 by 2, 1 by 2, 1 by 2. This was idempotent, but it is not a diagonal matrix with diagonal entry 0 or 1. So option 2 is discarded, and these two I have discussed in that results, third and fourth. So answer is option 1, 3 and 4. Let A belongs to 3 cross 3 matrix over R be such that A to the power 8 is equals to, then first option, minimal polynomial of A can only be of degree 2. Minimal polynomial of A can only be of degree 3. Either A is a 3 cross 3 identity matrix or minus identity. There are uncountably many A satisfying the above.
First and third.
Are you sure?
Let's see your calculator.
What was your approach?
I've taken the characteristics polynomial to be x to the power 8 minus 1. Then factorize it. Factors are x minus
X
1,
की
x
power
plus 1.
8 minus 1. Are
A
you
to the
sure?
power 8.
Are you sure? Because it is given that A is a 3 cross 3 matrix.
A is 3 cross 3. No? So by Cayley-Hamilton theorem, matrix satisfies the characteristics equation. So if we take A to be lambda, then lambda's power 8 minus 1. मतलब that means
मेरा मतलब ये है
फैक्टर्स
कि
की वहाँ फिर 8 एगन वैल्यूज हो जाएंगी ना, तो वेक्टर से 3 क्रॉस 3 की है.
हाँ यही कह रही हूँ कि ये तो फिर बिल्कुल भी गलत हो गया ना, क्योंकि मैट्रिक्स का ऑर्डर 3 है और आइगन वैल्यूज हम कहें कि 8 है, ये तो इम्पॉसिबल है.
इम्पॉसिबल है, ठीक है. तो
अगर एक बार हम
a स्क्वायर इक्वल टू आई करें तो a 4.
a स्क्वायर इक्वल टू आई. हाँ
a स्क्वायर इक्वल टू आई, then a to the power 4. y power 4.
So if we take A as identity matrix, 3 cross 3 identity matrix, then what will be characteristic polynomial? What will be characteristic polynomial? X minus 1 cube, na?
Yes.
Now we need to find minimal polynomial. Eigenvalues are 1 and AM is 3. What about GM?
GM will be 0 0 0. So GM is 3 minus 0, 3 रहेगी.
3. So I need to partition this 3 in number of partitions at GM. मतलब 1 plus 1 plus 1. Highest factor is this. So minimal polynomial is
x minus 1.
And in options first and second, it is saying that minimal polynomial can only be of degree 2 or degree 3. So option 1 and 2 are discarded. Option first is also wrong. Option second is also wrong. Okay.
Or third one, if we take I, then it can be either A is minus I भी हो सकता है.
Or if I take another example, 1 0 0 0 1 0 0 0 minus 1. A square is A. 1 second. A square is I. Identity चाहिए ना. और A to the power 8 वो भी I आएगा.
I आएगा. Yes.
So we are getting a 3 cross 3 matrix which is satisfying this property, and it is neither identity matrix neither minus I. So option 3 is also discarded. Means they are uncountably many, है ना?
Yes.
So answer will be option 4. मतलब मैंने ना हर क्वेश्चन में ऐसे अप्रोच सोचती हूँ कि कम से कम थ्योरी हो और एग्जाम्पल अप्लाई करके कर पाए। एग्जाम्पल से डिस्कार्ड करेंगे तो जल्दी होगा, है ना? तो एग्जाम्पल से इनमें जल्दी से डिस्कार्ड हो गया। मतलब ज़्यादातर कोशिश करो कि एग्जाम्पल से ही जाओ। हर जगह
बट
थ्योरी
इसमें आई आइडेंटिटी मैट्रिक्स से भी तो हो सकता है ना, नहीं हो सकता है?
आइडेंटिटी से हुआ है, सेटिस्फाई कर रहा है प्रॉपर्टी, बट इशू ये आ रहा है कि उसने कहा है कि मिनिमल पॉलिनॉमियल ऑफ ए कैन ओनली बी ऑफ डिग्री 2 या डिग्री 3, बट आई वाज
वो
गेटिंग
तो ठीक है, हाँ वो तो ठीक है, वो डिस्कार्ड हो गया, बट थर्ड ऑप्शन भी तो करेक्ट हो सकता है।
थर्ड ऑप्शन इज सेइंग दैट a matrix of order 3 cross 3 which is satisfying this property is either identity matrix or either minus identity matrix, but I am getting another matrix of this type na.
ठीक है, क्लियर है।
So next we will discuss symmetric, skew symmetric and orthogonal. So symmetric matrix was A transpose is equals to A, and eigenvalues of a real symmetric matrix are real. So for example, if I take a complex symmetric matrix, A transpose is clearly equal to A. This is not a real matrix. Then what will be its eigenvalues?
आएगा आएगा बस।
Iota, iota. I am not getting any real eigenvalue because matrix was not real. So eigenvalues of a real symmetric matrix are always real. Next is skew symmetric. Skew symmetric. So what do you understand by skew symmetric matrix? A transpose is equals to minus A. Here also eigenvalues of eigenvalues of real skew symmetric matrix are purely imaginary or zero. For example, if I have a 3 cross 3 matrix, first of all, I have discussed this now, that A transpose is equals to minus A, means AJI is equals to minus AIJ. This implies AIJ plus AJI is equals to 0. And if I is equals to J, means what about diagonal entries? AII,
zero.
0. This means that diagonal entries of a skew symmetric matrix are 0. And if I have 1 here, then it will be minus 1 here. If I have 2 here, then it will be minus 2 here. If I have 3 here, then it will be minus 3 here. So this is skew symmetric matrix. So इसकी जो आइगन वैल्यूज होंगी they will be either purely imaginary or zero. Now next thing, we know that A transpose is equals to minus A. If I apply determinant on both the sides, do you remember this property of determinant? If A is a n cross n matrix, then this scalar comes outside as k to the power n,
Yes.
determinant of A. So here minus 1 to the power n, determinant of A. This will be determinant of A. Now I have two cases from here. If n is even, then determinant of A is determinant of A only. And if n is odd, then determinant of A is equals to minus determinant of A. This means determinant of A is 0. Means if I have a odd order skew symmetric matrix, then its order is then its determinant is 0. Singular odd order skew symmetric matrix. So if determinant of A is 0, this means that 0 must be an eigenvalue of an odd order skew symmetric matrix. जैसे यहाँ पे डिटर्मिनेंट निकालने की कोशिश करें, 0 minus 1 0 plus 6 plus 2 3 0 आ रहा है ना, क्योंकि this was odd order, n was 3 odd. Next is orthogonal matrix. So A transpose is equals to A transpose A is equals to identity. Means if I multiply a matrix with its transpose, then it should be identity. This means that A transpose is equals to A inverse. And eigenvalues of real orthogonal matrix are of unit modulus. This means that you can say that all the eigenvalues of an orthogonal matrix lies on a unit circle. Unit modulus means mod z equal to 1. If z is x plus iota y this type, then by squaring on both the sides means unit circle. Let lambda be an eigenvalue of A. A is orthogonal matrix. So if lambda is an eigenvalue of A, then eigenvalue of 1 by A means eigenvalue of A inverse will be 1 by lambda, na?
Yes, ma'am.
Okay. So if I have a 5 cross 5 matrix and if it is orthogonal, then I can say that if one eigenvalue is alpha, then other eigenvalue will be its inverse 1 by alpha, beta 1 by beta, and 1 or minus 1, because I have already told you that eigenvalues of real orthogonal matrix are of unit modulus. For example, if I take another example, A is equals to 1 by 9, 4 by 9, 8 by 9, 8 by 9, minus 4 by 9, 1 by 9, minus 4 by 9, minus 7 by 9, 4 by 9. So I am telling you another thing. वैसे तो ये inner product space के time पर पढ़ेंगे. Do you remember how to check orthogonal vector?
Yes, sum of the products of two rows should be 0.
Sum of
The square of the vectors will be 1 in a row.
Means V1, inner product of V1 and V2 is 0. Inner product of V2 and V3 is 0. Inner product of V1 and V3 is 0. Or you can say that inner product of any two rows is 0. So by this method it will be helpful, because if you check like this, A transpose is equals to A transpose A is equals to identity, then it will be lengthy. But this can be done mentally. So V1 and V2 inner product, 8 by 81 minus 16 by 81 plus 8 by 81. It is 0 na? Similarly, minus 32 by 9 plus 28 by 81 plus 4 by 81. Again it is 0. And V1 and V3 minus 4 by 81 minus 28 by 81 plus 32 by 81. Again it is 0. So clearly matrix A is orthogonal. So tell me whether every orthogonal matrix is non-singular or not.
It is non-singular.
Because all the eigenvalues are of unit modulus.
Unit modulus.
So all the eigenvalues will be non-zero. And if it is non-singular, then we can say that every orthogonal matrix is invertible. Because determinant is non-zero, means A inverse will exist. And if A is orthogonal, then A transpose and A inverse, these are orthogonal. So A is orthogonal means A transpose is equals to A transpose A is equals to identity. Now I need to check A transpose. Means instead of A, I will put A transpose. A transpose ka transpose. It will be A again. And from this side, A transpose ka transpose A transpose. Again it is A transpose. And A transpose A is identity. A transpose is identity because A is given to be orthogonal. This means that A transpose is orthogonal. Similarly, A inverse can be checked. So do you know what is a normal matrix? Before that, I should tell you unitary and Hermitian. What is a Hermitian matrix?
A conjugate transpose is equal to A.
A conjugate transpose is equals to A. Sometimes we also say that like this, A to the power theta is equals to A. This is the same thing. So for example, if I try to construct a Hermitian matrix of 3 cross 3 order, 3, 1 minus 2 iota. If I have 1 minus 2 iota here it will be its conjugate, 1 plus 2 iota. 4 plus 7 iota, then its conjugate, 4 minus 7 iota. Minus 4, minus 2 iota, then here it will be its conjugate, 2 iota. 2. So this is Hermitian. And what do you understand by skew Hermitian? A conjugate transpose is equals to minus A. Means A to the power theta is equals to minus A. For example, minus 4 plus iota. Now here conjugate will also be there and it will be multiplied by minus sign. So what will be its conjugate? Minus 4 minus iota and multiplied with a minus sign. 4 plus iota. 3 plus 2 iota. Conjugate is 3 minus 2 iota multiplied with minus sign, minus 3 minus 2 iota. Minus 3 plus 2 iota. Conjugate of minus 2 plus iota, minus 2 minus iota multiplied with minus sign, 2 plus iota. So this is skew Hermitian. Here also all the diagonal elements of a skew Hermitian matrix are either 0 or purely imaginary. In this example, all the diagonal entries were purely imaginary. Now next is unitary matrix. Do you know what is unitary matrix?
It is A square equal to I. नहीं वो तो इनवॉलिड होती है ना. This is matrices. ज़्यादा माइंड में आई थिंक conjugate भी I आता है. It is similar to orthogonal ना.
बस जो हर्मिशियन वाली प्रॉपर्टी थी वो इसमें आ जाती है साथ में. So A conjugate transpose is equals to A conjugate transpose A is equals to identity. This is unitary matrix. For example, A is equals to 1 by 2, 1 minus iota. Here also conjugate iota. Minus 1 plus iota. 1 plus iota. 1 plus iota. Minus 1 plus iota. So this is complex matrix. And one more thing, if I write it like this, a to the power theta is equals to a to the power theta, a is equals to identity. So this means that a inverse is equals to a to the power theta. And if I want to find what will be its determinant, a theta is equals to identity is equals to a to the power theta a. If I apply determinant on both the sides, what is determinant of identity matrix? 1. And this will be determinant of a theta. So this will be determinant of a square equal to 1. This means that the determinant of a unitary matrix is of modulus unit. This means that it is like same as orthogonal matrix, but main difference was that in orthogonal matrix, matrices were real. Here matrices are complex. So accordingly, this definition was defined. Now next is normal matrix. Normal matrix is simply a theta is equals to a theta a. Now some results. Every normal matrix is diagonalizable. Real symmetric, skew symmetric, and orthogonal matrices. These are normal matrices. It is a conjugate transpose is equals to a conjugate transpose a. So if I want to see that real symmetric matrix is a normal matrix, real symmetric matrix, A transpose is equals to A. So we can directly check this definition. Conjugate will be removed because it is a real matrix. So A transpose is equals to A transpose A. So this is satisfying definition of normal matrix. Similarly, other matrices can be checked. Next, real symmetric matrix are diagonalizable. Real skew symmetric matrix are also diagonalizable. Real orthogonal matrix is also diagonalizable. For example, is this an orthogonal matrix?
Yes.
1 by root 2, 1 by root 2, 0, 1 by root 2, minus 1 by root 2, 0, 0, 0, 1. What about this?
This is also orthogonal.
Hmm. This is a very popular example of orthogonal matrix. This is also orthogonal. Let A is equals to x, y minus y, x, where x comma y belongs to real numbers such that x square plus y square is equals to 1. Then we must have try this question. I will be back in a minute. Got the answer?
Yes, first, third, and fourth.
Yes. 1 second. What was your approach?
Uh, Simple, like a x is cos theta by n, y sin theta by n. So we have studied this result by induction. A for n is we will multiply the n in within the matrix to the angle. So we'll get cos theta sin theta minus sin theta cos theta. So first option is correct. Then in the second, if I take the matrix as 1 0 0 minus 1, so that is orthogonal, but trace is 0. Here trace is not 0. So second I have discarded. Third is simpler property, third and fourth. Because this is orthogonal matrix.
So for option 1, x is cos theta by n, y is sin theta by n. So A will be cos theta by n sin theta by n minus sin theta by n cos theta by n. So A to the power n will be cos n theta by n sin n theta by n minus sin n theta by n cos n theta by n. This is cos theta minus sin theta cos theta. So option 1 is correct. And in option 2, it is saying that trace of A is non-zero. If I take x as 0 and y as 1, then matrix A will be 0 1 minus 1 0. Clearly this matrix A is satisfying this x square plus y square equal to 1 this property also, and trace is 0. So option 2 is discarded. And option 3, I have already told you that A transpose is equals to A inverse, which can be easily verified. So in fourth also, we know that A is a orthogonal matrix, and every orthogonal matrix is diagonalizable over C. So option 4 is also correct. A is similar to diagonal matrix over C. Next question. Which of the following are eigenvalues of the matrix hmm.
It's A and B.
Reason?
It is orthogonal matrix, so eigenvalues are plus minus 1.
What about eigenvalues of this matrix?
It is 1, 1, minus 1, minus 1.
If A is equals to 1 iota 0 0 minus 1 plus iota root 3 by 2 1 plus 2 iota 0 0 minus 1 minus iota root 3 by 2, then the trace of A to the power 102 is option A 0, option B 1, option C 2, option D 3. So firstly, what are the eigenvalues of A?
Its diagonal entry is only 1 minus 1 plus iota root 3 by 2 and minus 1 minus iota root 3 by 2.
And this is cube root of unity, na? 1 omega square.
Yes.
So eigenvalues of A to the power 102. 1 to the power 102, omega to the power 102, omega square to the power 102. So what will be this? 1. This will be omega cube and this na omega to the power 102 and omega cube is 1. So this will be 1.
Again, next is also 1.
So trace of A to the power 102 will be 1 plus 1 plus 1 means 3.
3.
So answer is option D. Let n is equals to 3 by 5, 4 by 5, 0, minus 4 by 5, 3 by 5, 0, 0, 0, 1. If M is any 3 cross 3 real matrix, then trace of n transpose is equal to
It's option C. Trace of M.
reason.
It is a property, na? Trace of ABC is a trace of CAB.
Trace of ABC is
Trace of CAB. And that means N transpose NM. So N transpose N is identity because it is orthogonal matrix.
This implies n transpose is equals to identity. So it is equal to trace of M only. Let T mapping from R4 to R4 be defined by TXYZW x plus y plus 5w x plus 2y plus w minus z plus 2w 5x plus y plus 2z. The dimension of the eigenspace of T is option A 1, option B 2, option C 3, option D 4.
That means it is a set of all non-zero eigenvalues. Iron space is the set of eigenvalues. No?
We are asked to find the dimension of eigenspace of T.
So it will be rank only.
It is GM, na? I have discussed na. GM is number of Li eigenvectors. So,
yes, so iron space is the iron vectors.
If you write the matrix representation of this T with respect to ordered basis of R4.
I've written that. Yes.
What was that? Simply?
It is 1105, first column. 1105. 1201. 00 minus 12. 1120.
5122. है ना?
5. Oh, sorry. अच्छा. Yes,
So,
5122.
So,
नहीं 20 आएगा ना लास्ट में 2Z ना
0. Yes, 0.
0.
So this is a symmetric matrix.
Yes.
Real symmetric matrix. And I have told you that real symmetric matrix is diagonalizable. This means that number of Li eigenvectors is 4. Whenever matrix is diagonalizable, then number of Li eigenvectors is equal to the order of the matrix. Here order of the matrix is 4 cross 4. This means that GM is 4 and GM is dimension of eigenspace of T. That's why dimension of eigenspace is 4. Because otherwise, if you find eigenvalues, then AM, then GM, it will be lengthy, na? This approach is easy. Because directly symmetric matrix is diagonalizable. So number of Li eigenvectors is equal to the order of the matrix. So dimension of eigenspace is 4. Because dimension of eigenspace is GM and GM is number of linearly independent eigenvectors. The possible set of eigenvalues of a 4 cross 4 skew symmetric orthogonal real matrix is A part plus minus iota
It's A part plus minus iota.
reason.
See, eigenvalues are purely 0 or imaginary. Purely imaginary or 0. So in first option we are getting only this option.
0 or purely imaginary.
Yes.
Also, it is orthogonal, na?
Yes.
Means eigenvalues will be non-zero.
And trace is 0. because Q symmetric है ना,
Hmm.
the diagonal entries will be 0.
So this means that option D is not possible as it is Q symmetric. So only possibility is option A only. This question is on the concept which I have discussed yesterday.
It's option D. या फिर ऑप्शन बी.
Reason?
See, rank of A plus B should be less than or equal to. मैं फर्स्ट ऑप्शन तो डिस्कार्डेड ही है, वो तो हो ही नहीं सकता है ना. सेकंड वाला rank of A plus B less than or equal to rank of A plus rank of B. It can be because अगर हम A रैंक ए और रैंक बी की दो मैट्रिसेस ऐसे नहीं कि में फर्स्ट रो 0 है, फिर उसको ऐड करेंगे तो अच्छा. It is also discarded.
So it is
D
best.
option. D option is correct one according to me.
If I take identity matrix of 2 cross 2 order and B matrix has minus I.
अच्छा ठीक है, बी भी आएगा, ठीक है, बी ऑप्शन भी करेक्ट.
So A plus B is 0 0 0.
0 0 0.
Rank of A is 2, rank of B is 2, rank of A plus B is 0. So option A is wrong.
B is correct.
And
Minimum.
option C is also wrong. And D is also wrong by taking a single example.
Yes.
So answer is option B. If P and Q are invertible matrices such that PQ is equals to minus QP, then we can conclude that trace of P is equals to trace of Q equal to 0. Trace of P is equals to trace of Q equal to 1. Trace of P is equals to minus trace of Q. Trace of P is not equal to trace of Q. Try this.
It is A part and C part.
What was your approach?
I pre-multiply by Q inverse on both sides, PQ and minus QP, because it is given an invertible.
PQ is equals to minus QP.
Mm.
So you can do this in two ways. You can post multiply by P inverse.
Mm.
Then it will be PQ, P inverse is equals to minus Q.
Mm.
This
Mm.
means that Q and minus Q are similar matrices.
Okay. Yes. So similar have same trace.
And trace of minus Q can be written as minus trace of Q.
Mm.
So this means twice of trace of Q is 0. Trace of Q is 0. Okay. And in the similar manner, we can pre-multiply by Q inverse.
Yes.
Q inverse PQ is equals to minus P. This means that P and minus P are similar
Similar.
matrices.
Mm.
Then trace of P is 0.
Mm.
So trace of P is equals to trace of Q equal to 0.
Mm.
So option A is correct. And option C is saying that trace of P is equals to minus trace of Q. It is also correct. Trace of Q is 0 and trace of P is 0. So it is satisfied. So answer will be options A and C. Which of the following is always true? A is non-singular. B is non-singular. A plus B is non-singular. AB is non-singular.
B is non-singular.
Reason?
मैंने तो इसको लाइक टास्क फर्स्ट तो मैंने अगर लिया तो ए इज नॉन सिंगुलर देन ए इनवर्स से मल्टीप्लाई किया दोनों साइड पोस्ट मल्टीप्लाई किया जैसे तो बी इंटू ए इनवर्स प्लस बी स्क्वायर ए इनवर्स आई ए इनवर्स माइनस बी स्क्वायर ए इनवर्स so it becomes b plus b square inverse and then a inverse and ba. So if we club all ba one side, so take b common and in bracket I get 1 plus a plus b inverse equal to a inverse. So a inverse to exist, b should be non-singular.
ऐसे करा था, ऐसा कुछ?
हाँ हाँ ऐसे ट्राई किया कुछ. Yes, then I've taken ba that side. Yes. So right hand side we have a inverse. So for a inverse to exist, b should also non-zero, na?
Yeah.
If I take determinant on both sides, so determinant of b should be also non-zero. So b should be non-singular.
या फिर अगर एग्जांपल लेके कर ले. If I take A matrix as zero matrix, B as identity matrix, then clearly this condition hold. And here A is singular and B is non-singular. And AB is again zero matrix, so singular. So by taking this, option A and D are discarded. Now I can change the example. I can take A as minus identity, B as identity. And it was BA plus B square equal to identity minus BA square. So again it is identity into minus A plus identity equal to identity minus identity into A square. So this is minus identity, this is also minus identity. So this is also satisfied. And here A is non-singular and B is non-singular. And A plus B is zero matrix means singular, na? So by taking this, option C is discarded. So answer is option B. B is non-singular. Let A be a n cross n matrix whose entries are aij. N is greater than equal to 3 where aij is equals to bi square minus bj square. Ij is equals to 1, 2 up to n for some distinct real numbers b1, b2 so on till bn. Then determinant of A is option A, product of I less than j, bi minus bj, Product of I less than j, bi plus bj, 0, 1.
Determinant is 0. See,
कैसे करा?
स्क्यू सिमेट्रिक मैट्रिक्स है ना.
स्क्यू सिमेट्रिक.
अच्छा, मैंने n इक्वल टू 3 ले लिया, n इक्वल टू 4 भी करके देखना पड़ेगा ना.
अगर n इक्वल टू 3 ले रहे हो और 3 क्रॉस 3 की होगी
तो ये आएगा 0 देन b1 स्क्वायर माइनस b2 स्क्वायर.
इनको भी कुछ ले लेते हैं.
ठीक है, तो b1 को स्क्वायर नंबर लेना है, कुछ भी ले सकते हैं ना. 1 2 3 ले लेते हैं.
-1 ले लेते हैं, कुछ भी ले सकते हैं. डिस्टिंक्ट लेने हैं लेकिन.
हाँ, b1 1 2 3 3 3.
b2 0, b3 1. So this will be a11 b1 square minus b1 square. So b1 square minus b1 square 0. फिर a12 b1 square minus b2 square 1. b13 b1 square minus b3 square. So 1 minus 1 0. And similarly b2 1 यानी कि b2 square minus b1 square. So 0 minus -1 square minus 1. b22 0. b23 0 minus 1. b31 0. b32 1. And b33 0. This is skew symmetric matrix. And I have told you that odd order skew symmetric matrix has determinant
0.
0. So answer is option C, because all the remaining options will be discarded. It is product of I less than j, bi minus bj. I should be less than j. b1 minus b2, b2 minus b3, b1 minus b2 minus 1 minus 0, 0 minus 1,
Plus 1.
1. So it is not possible. Similarly, C option can be checked. B. bi plus bj, b1 plus b2, b2 plus b3, -1 plus 0, 0 plus 1. This is -1. B is also discarded. D is also not possible.